One of your classmates had a question, so I wanted to deal with that question before we go on. And that was a double integral question. So the question is, first off, we had to compute the integral from 1 to e squared, the integral from 0 to log x of xy dy dx. And one of the things you had to do was compute the integral, identify the domain or the region, and then switch the order of integration. So if we're doing this integral, I just wanted to do this for anybody who might need it, and definitely for the student in the class who needed this problem. So where does y go from? Well, y starts at 0. And it goes to log x. And where does x go from? Well, x starts at 1. And it goes to e squared. So if I were to draw that region, I would have y goes from 0 up to the curve y, log x. So if I were to graph the log of x, it would look something as such. Well, I should have drawn the other one, but actually I only need to do it from 1 on. So the log of x looks like this. And it goes from 1 to e squared. So this is the region R in the XY plane. So as you can see, y starts off at 0, goes all the way to the log of x, and then x sweeps from 0 to 1. So this is what the picture would look like. Okay, if we were then computing this, well, let's switch the order of integration. So to switch the order of integration, that means I would fix a y and see where x goes from. So if I fix a y, I would see that x would start at this curve and go to that. And then I'd have to figure out what that value of y is. So this curve, which is y is equal to the log of x, I'm going to take y is equal to the log of x, and I'm going to change it to x is e to the y. So therefore, I now get that 0 is less than or equal to x. No, sorry. X is going to start off at the curve e to the y, less than or equal to x, and it's going to go all the way up to where x is equal to e squared. And then where does y go from? Well, I have to figure out what this point is. So if if x is e to the y squared, e squared, then this point right here would be y, would be the log of e squared. So that's just 2. So now I know this is 2. And so then y is going to start down here at 0. It's going to go up to 2. So the new integral is that y is going to go from 0 to 2. And x is going to go from e to the y to e squared of xy dy dx. Any questions there?
No.
Everybody okay with that? Okay. Let me see. I think I had another question.
Isn't it dx dy?
What did I write? It is dx dy. It's dx dy. Okay. And then another student also had a question. So I want to answer those questions. I should have checked to see if these students are even on here before. I think they should be. Yeah, they're on here before I go answering their questions. So they're on here. Okay. So yes, that should be dx dy. You get so used to writing dy dx. Okay, so that was one question. And so another student asked the question, how do you find dy dx for this problem? 3x squared, I guess that's equal to, I can't even tell what that is. I think this is f of x, y. Is equal to 3x squared minus 5xy plus the tangent of x. Okay, so I think this is Fahim's question. The other question was in Deja's question. This is Fahim's question. Okay, so we want to find dy dx. So we have, we have that f of xy is equal to 0. So we know that dy dx is minus f sub x divided by f sub y. So what is f sub x? F sub x is 6x minus, take the derivative with respect to x, and that's going to give me 5y. And then the derivative of tangent is secant squared of xy. And the derivative with respect to x is just y. And then fy, well, the 3x squared goes away, so I get minus 5x. And then I'm going to get secant squared of xy. And the derivative of xy with respect to y is going to pull out an x. So therefore, dy dx is minus 6x minus 5y plus y times secant squared of xy divided by x secant squared of xy minus 5x. So you can use it like, you can leave it like that, or you can push the negative through and simplify. Okay. So that was correct. Then this next one was also one that was on the project. It's a Lagrange multiplier problem. and f of xy was equal to x squared y squared, and the constraint is 4x squared plus y squared is equal to 8. So you get g of xy becomes 4x squared plus y squared minus 8 is equal to 0. So I need to find the gradient of f is lambda times the gradient of g. So the gradient of f, so f sub x is going to be 2xy squared, and f sub y is going to be 2x squared y. And then g sub x is 8x, and g sub y is 2y. So that gives me that 2xy squared is lambda times 8x, and then 2x squared y is equal to 2y. So I can do either one. Oh, I'm missing a lambda. Lambda times 2y. So I can do either equation, whichever one works for me. So I like the second one, so I'm going to start there. So I get 2x squared y minus lambda times 2y is equal to 0. So I'm going to factor out 2y. And when I factor out 2y, that gives me x squared minus lambda is 0. So I get two things. Either y is 0 or lambda is x squared. So if y is 0, I'm going to plug that into my g. So g of x and 0 just becomes 4x squared minus 8 is equal to 0. And so I get x squared is equal to 2. So x is equal to plus or minus 2. So I get the point plus or minus 2 and 0. And then if lambda is equal to x squared, I'm going to plug that into the first equation, and I get 2x y squared is equal to lambda, which is x squared times 8x. So now I get 2x y squared minus 8x cubed is equal to 0. So I can factor out the 2 and an x, and that's going to leave me y squared minus 4x squared is equal to 0. So now I get y squared is 4x squared. So now I'm going to find g of x and y, but I'm going to plug in this. So I get 4x squared, and y squared is 4x squared minus 8 is equal to 0. So that says 8x squared is equal to 8. X squared is equal to plus or minus 1. So therefore, so does y. Okay. So I have now plus or minus 1 can go with plus or minus 1. Oh, that's wrong. So now I get y squared is 4, so y is equal to plus or minus 2. Okay. Now, this is actually 2 points. And this is actually 4 points. So now I need to check 6 points. So I get F, but I can check them kind of together because F is x squared plus y squared. Am I correct? Yeah. So all 4 of those points are going to give me 0. And F of plus or minus 1 plus or minus 2 is going to give me 4. So therefore, this is the minimum or the absolute minimum, and this is the absolute max. Okay. Any other questions?
We do one of the double integral polar coordinate problems,
Okay, we can.
or like a triple integral one. I mean, it doesn't really matter.
Okay, well, I had some more triple integral stuff, but they are not polar. So let me see.
Oh, okay.
The example, that's okay. Let me find the examples I had, I don't believe were polar. This one's not polar. And this one is neither. If you have one that you want me to do,
Oh yeah, I'll send it through. Yeah.
I'm trying to see if I can find one.
Yeah. Let me.
Those are all rectangular. Believe it or not, when you have the volume is the triple integral over T of some F of R theta and Z R dz dr d theta. This is actually called cylindrical coordinates. Because once you add a Z component to something that looks like a circle, you have a cylinder. So that's actually cylindrical coordinates. Did you find a problem?
Yeah, I have a double integral one. Yeah.
Okay.
Um,
This is a double integral problem, not a triple?
no, we didn't do triple in polar coordinates, did we?
Yeah, we did.
Oh, we did?
I didn't give you an example. I didn't have it. Yes, we did. We did.
Oh. Well, okay. So using polar integration, find area of region R in the XY plane enclosed by the circle x squared plus y squared plus 4 above line y equals 1 and below y equals square root 3x.
Okay, say that again, please.
Yeah. Find area of region R in XY plane
Hold a minute. Of the region R in the XY plane. Okay, well, go ahead.
enclosed by circle x squared plus y squared plus 4.
Enclosed by x squared plus y squared is equal to 4. Okay.
Oh no, plus 4, plus 4.
X squared plus y squared plus 4?
Yeah.
No, that's not right.
Let me check.
It can't be. If it's a circle, it's x squared plus y squared equals 4.
Oh, that's weird. It says plus 4, but I don't know. And it says maybe if we do equals. Oh no, I think it's supposed to say equals 4. It might be a typo. Yeah.
Okay.
Yeah, I'm pretty sure it's equals 4. Above the line, y equals 1, and below y equals square root 3x.
I did that one.
Oh, did you?
Yeah.
Oh, let me see. Oh, never mind.
Okay.
My bad.
All right. So I want to do 2 more triple integral problems. So this one is compute by triple integration. The volume of the region T that is bounded by the parabolic cylinder x is equal to y squared and the planes z is equal to 0 and x plus z is equal to 1. Okay, so what does that look like? Okay. So there's a parabolic cylinder. Where's my line? Why is, okay. Here's my parabolic cylinder. So this is the parabolic cylinder coming around like this. Okay, but this thing is bounded by the parabolic cylinder and the plane. So there's a plane. So I'm going to draw okay. Uh-oh. Why'd you disappear? So it's a wedge. Like a wedge of cheese. Okay. Maybe if I had drawn it, I should have drawn it myself. That would have been better. Let's see. It's always hard to draw these things. Well, I'm going to leave it like that. Hopefully y'all get the idea. Okay. All right. So on the top is the plane x plus z is equal to 1. So we're going to write that the top, z top, is z is equal to 1 minus x. Okay. So that's the top. So I already know that z goes between 0 and 1 minus x. So now I need to figure out the xy plane. So in the xy plane, I have a parabola that is facing in the x direction that looks like this. So the only part that I'm concerned about is this piece right under here on the ground. And that is this right here. Okay. So when z is equal to 0, this is hitting in the line x is equal to 1. So I can clearly see that x goes between the curve y squared to x equals 1. And then where does y go from? Well, if x equals 1 and this is the curve x is equal to y squared, then this height is 1 and this height is minus 1. So y goes between minus 1 is less than or equal to y. It's between 1. So the volume becomes y goes from minus 1 to 1, x goes from y squared to 1, and z goes from 0 to 1 minus x. And then I want the volume, so I need dz dx dy. And this turns out to be 8/15. Now, I could have done it a different way, but by far, that's the easiest way to do it. Okay. Any questions? You guys seem to have all this under wraps. You don't have any questions before the exam on Monday? Because
Is it
I'm,
gonna
yes.
is it gonna be like the last one where we have to do where there's 5 problems but we can only choose like 4?
I don't know. I have to, I haven't seen what the problems are yet. How many sections are there? I said 15, 14 point what?
15.1 to 15.5, so like 6.
So there are 5 sections. It's possible. Did y'all like that format?
Yeah, I liked it.
Yeah.
What did you like about it?
I feel like it took less time and we had a chance to get extra credit with the last problem.
Okay.
Yeah.
I may consider that again. I can't promise that, but I will definitely consider it since that seemed to work well for you guys.
Also, are you counting course evaluations for extra credit or not?
No, I'm not allowed to do that legally.
Oh, okay.
I can't. You guys have to do the course evaluations based on your own integrity and merit. If I give you extra credit for it, then it's kind of like I paid you to do it. So I can't do that. I really do need you to do them though. How about that? Why don't we take the time now to do those?
I already did mine.
Oh,
I
you
was just
did?
wondering. Yeah.
Okay. All right. Any questions, guys? I pretty much have covered everything. So what I'm going to be doing on Monday and Tuesday and Thursday is severe review for the final.
Dr. Lott,
Yes.
project 4 was optional, right?
Project 4 was optional. So if you did not, I'm dropping. So what's going to happen is if you did not do project 4, I'm going to put a 0 in that spot. And then it's going to drop the lowest grade so that 0 will disappear.
Okay.
For those people who did project 4 and wanted to improve their grade, if this is better than any other project, it'll make the lower project disappear.
All right.
I think I had 6 students turn in project, 6 or 8 students turn in project 4.
That high up, so nice recognition and text.
You guys don't have any other questions for all this free time? Okay.